Welcome to February 21st LeetCode Challenge. Single element in a sorted array. You're given a sorted array consists of only integers where every element appears exactly twice, except for one element, which appears exactly once. Return the single element that appears only once. The solution must run in big O of log n time and big O of constant space. So just by inspection, you see this array of nums has a bunch of numbers in it that are doubles. We can see kind of right away that 2 is the one standing out. So therefore, return 2 as the number that's basically a single element. Keep in mind that it is sorted, so it's pretty easy to recognize. So basically, we see here, this in example number 2, 10 is the odd one out. It has a single element that only appears once. And that's pretty much the gist of it. Constraints are that the length of nums between 1 to 10 to the 5, and each index of nums is between 0 to 10 to the 5. So let's take an approach to this. So we see how that each, basically we have to find the single element that appears only once, and the hardest part of this, or what makes it a challenging question, is that these are the time constraints. The solution must run a big O of log n time and constant memory or space. So say if we were to implement a binary search approach to find a single non-duplicate element in the sorted array of integers, that would make it probably big log n. So say we develop an algorithm that does the following. The first thing we want to do is basically, if the input array, what am I doing? Input array has only one element, then return that element. Return that single element, because it is non-duplicate. Next thing, second condition you want to check is initialize a left and right pointer, 2 pointers, left and right, left pointer and right pointer, to the start and end of the array, and respectively, of course. And this is going to be our binary search approach. And then we want to do a while loop or something, while a certain, let's say, while loop, to basically find if the index is less than the current right pointer, and then do some other type of analysis on it. Let's just kind of follow this through. So if nums.length is equal to 1, return nums at index 0. That's pretty much it for that one. Next thing you want to do is initialize some left and right pointers. So I'll call this left 0, initialize right pointer to be nums.length minus 1. Alright, put some space here. Then we'll do a while loop to basically check if left is less than right. Then we want to do the following. So we want to find the midpoint. And we find the midpoint by doing this. So mid equals left plus right minus left divided by 2. 2. And then we do an if statement to check the middle number. So basically, I'm just gonna write it out. So if nums at the midpoint is equal to the number at midpoint plus 1, then it is a candidate to be updated. So therefore we update mid to be mid plus 1. Oh, minus 1 I should say. Put space here. So that's the first if statement. The second if statement would be how do I say this? If the midpoint minus left plus 1 is not divisible by 2. So meaning that you have mid minus left plus 1. Take the modulus of that with 2. If that's not equal to 0, then we can update our right pointer to be mid. Okay, we got the two statements there. These are to the logic within the while loop. And then the last one is just an else statement, which basically meaning update our left pointer to be mid plus 1. So basically this is our binary search. We exit this while loop. And then we just have to return the number that is a single element that appears only once, which is going to be nums at the left pointer index. Let's take this a go. Alright, looks good. Nice. Okay, it works. So basically time complexity is big O of log n, and space complexity is big O of constant space. So to kind of go over this, basically what we did was that we checked the midpoint of the current range using the formula as such. Basically left plus right minus left divided by 2, and which is basically define the midpoint. So we did that. If the element of the index of mid is equal to the element of the index of mid plus 1, that means that the non-duplicate element lies on the left side of the midpoint. Therefore, decrement mid by 1 and move to the left. And what we did here is a little bit odd, but basically we're checking for the parity of the range. So meaning that if we take the midpoint minus left plus 1, if the range has an odd number of elements, that means that the left non-duplicate element lies on the left side of the range. Therefore, we need to update our right pointer to the midpoint. If the range is an even number, that means that the non-duplicate element lies on the right of the range. Therefore, we update our left pointer to be our mid plus 1. Right? This is just basically checking the parity of the range. And then lastly, we want to return the index of the element where the single non-duplicate element will lie. Alright, that is all. Have a great day, guys.